Good morning, welcome to my laboratory. What you're looking at there is the circuit that I'm going to be demonstrating right now. The question is, you'll notice here that I have the gate connected directly to the earth ground and the negative pole, the negative rail of the run battery. So the gate is always pinned to the earth ground. And what I'm going to do is try to turn the MOSFET on by lowering the voltage of the source pin below the voltage level of the gate by adjusting this rheostat and supplying a battery voltage that's more negative than the zero voltage level of the battery that's going to be turning on the bulb. Well, actually it goes like this. Okay, so I'll be lowering, the gate is pinned at 0 volts, grounded. So I'll be lowering the voltage of the MOSFET from 0 volts to -9 volts on the source pin of the MOSFET. The gate is going to be pinned to ground. Okay, so here's the actual circuit here. I've moved around some of the connections on my MOSFET test board to reproduce the circuit that's on the schematic. And I have the main battery coming in, or rather from the power supply, the plus voltage to the bulb, to the drain of the MOSFET. The source then goes over to the wiper of the rheostat, just like that. And the other end of the rheostat goes to the negative pole of the everything's falling apart, of the 9-volt battery that I have over here and that I'll connect in a moment. Well, I might as well connect it right now. What the hell? Alright. Okay, so I've got the negative pole of the 9-volt battery connected to the bottom end of the rheostat. The positive pole of the 9-volt battery goes to the negative rail right here and is grounded. Okay, so the gate is always going to stay at 0 volts. Will I be able to turn on the light bulb? Will the MOSFET operate in a linear conductance range? Apparently so. Alright folks, you've just seen a MOSFET being turned on and controlled fully in its linear operation range, even though its gate is pinned, its gate is pinned to 0 voltage, the negative rail and earth ground, and the source is being lowered below that voltage by a second battery to produce a more negative voltage at the source. So we've effectively raised the gate voltage by lowering the source voltage. Got that? Once again, here's the circuit. Except I'm using a 12-volt bulb here, a 12-volt power supply, but everything else is just the same. Alright, thanks for watching more impossible tricks with MOSFETs.